Hello, this is Dr. Brown. In this video, we're going to go over test 3 practice. If you can understand the concepts and the calculations we do in this video, you should be in good shape and doing well on test 3. The very first 4 problems have to do with determining whether an equation defines y as a function of x. You probably will recall that you have a graph of a function that it has to pass the vertical line test, that for any value of x, you only get one value of y. If you had a graph that looked maybe like this, you might do a vertical line test and it will intersect the graph in 2 places, so it's not a function. So let's look at y equal x3. You notice that for any value of x, only one value of y, so it is a function. Now look at y squared equal 5 minus x squared. If you solve for y, you get plus or minus the square root of 5 minus x squared. So for any value of x you put in, like if you put in x equal 1, you get the square root of 4 plus or minus, which is plus or minus 2. So it is not a function. The same goes for number 3. It actually tells you y is equal to plus or minus the square root of 1 minus 9x. So it is not a function either. If you look at the quadratic function that we have here, y equals 3x squared minus 9x plus 6, one value of x produces only one value of y out, so it is a function. Now we're given a graph of a line that goes through the points minus 4 and 5 and minus 3 and minus 1. And we want to find an equation for the graph in slope-intercept form. And so we need to find the slope and also the y-intercept, and then write the equation. First of all, let's call the first point x1 and y1, and the second point x2 and y2. And recall that the slope is y2 minus y1 divided by x2 minus x1, which in this case is going to be minus 1 minus 5 divided by minus 3 minus 4, which is equal to minus 6 over 1, which is equal to minus 6. So the slope is minus 6. And then you recall that the equation of a line, if you're given a point and the slope is y minus y1 equal m times x minus x1. So we have y minus y1, which is 5, is equal to minus 6, the slope, times x minus x1, which is minus 4. And so now we'll write the equations y minus 5 equal minus 6. Watch your signs here. This will be x plus 4. So we get y minus 5 equal minus 6x minus 24. And then adding 5 to each side, we get y equal minus 6x minus 19 is the equation of the line. And we want to find the y-intercept. So y at x equals 0 is minus 6 times 0 minus 19 equal minus 19. So the y-intercept is minus 19. And if we extended this graph all the way down and extended the line, it will intersect at y equal minus 19. So that is problem 5. Problem 6 is a car rental company charges $100 per day plus 30 cents per mile travel. Determine the equation of the line that represents the daily cost by the number of miles traveled and graph it. Well, in this particular case, the slope, the amount per line is going to be, per mile is going to be 0.3. So C of x is going to be 0.3x plus the $100 charge per day that you pay, even if you don't drive any miles. And C at 300, if you drive 300 miles, it's going to be 0.3 times 300 plus 100 is equal to 90 plus 100 equal $190. Now we want to graph this, and I've already graphed it on the next page. And the graph is C of x equal 0.3x plus 100. And at 300 miles, you can see the cost will be $190. Now, the next modeling problem is we have a phone company has a monthly cellular data plan where you pay a fee of $10 per month and then a certain amount of money per megabyte of data. If a customer uses 20 megabytes, the cost will be $11.20. If he uses 130 megabytes, the monthly cost would be $17.80. We want to find a linear equation that computes the cost versus x. So we really need to take 2 points that we're given. We have an x and a y. When the x is 20 megabytes, the charge is $11.20. When the x is 130 megabytes, the cost is $17.80. And we're going to call the first x, x1, the second x, x2, first y, y1, and the second y, y2. And we're going to find the slope of this line. So the slope m is going to be y2 minus y1 divided by x2 minus x1, which is $17.80 minus $11.20 divided by x2 minus x1, which is 130 minus 20. So that is equal to $6.60 divided by 110, which is 0.06. So now we get the cost versus x, the number of megabytes used, is going to be 0.06 times X plus the $10 charge. And they wanted us to find the cost for 250 megabytes. It's going to be 0.06 times 250 plus 10, which is equal to 15 plus 10 equal $25 for 190 megabytes. So the answer to this is $25. And of course, the equation C of X is equal to 0.06X plus 10. Now, number 8, we got an isotope of carbon. Carbon-14 is said to be radioactive. It spontaneously degrades into something else in a way that its amount or of mass is halved every fixed interval of 5,730 years. A living body should contain, say, m sub 0 kilograms of C14. Upon death, after 5,730 years, the body will be left with half of that. Another 5,730 years later, there will be 0.25 kilograms. That's M0 left of C14. If M is the mass variable of this radioactive mass at any time t, the variable M versus t is what kind of function? Well, it's pretty obvious that every so many years, which is 5,730 years, the amount of radioactivity goes down by a factor of half. So if M0 is the beginning amount, the amount at any time is going to be M0 times 1/2 to the t over 5,730. Notice we're dividing by 5,730 because when t is 5,730, the exponent will be 1, and it'll be 1/2 times the previous amount. And then after twice that amount, it'll be down to 1/4. So what kind of function is this? It is an exponential function. In fact, I would say it's exponential decay. Notice that if this factor from time to time is less than 1, it's exponential decay. If it actually grew, if that were more than 1, it would be exponential growth. So anyway, it's an exponential function, and we would call this exponential k. It's not quadratic, it's not linear, and I just made up suspenseful function. We have two problems here that we want to calculate the vertex axis of symmetry and the y-intercept of the graph of this function, and then answer the question, does the graph open up or down? Well, let's look at number 9. we want to find the axis of symmetry, which will be x equal h equal minus b over 2a. A is minus 3, b is 12. So in this case, minus b is minus 12 over 2 times a, which is minus 3. This is equal to 2. So this is equal to the x value of the vertex. The y value of the vertex is k, which is just going to be the functional value of h. Just plug this in to the original equation, and you get minus 3 times 2 squared plus 12 times 2 equal minus 12 plus 24 equal 12. So the vertex is 2 and 12. The y-intercept would be f of 0. Plug in 0 to get the y, and you get minus 3 times 0 squared plus 12 times 0 equals 0. So the y-intercept is 0 and 0. Now, the second one here, number 10. Oh, by the way, this a is less than 0, so it opens down. Number 10, we want to calculate the axis of symmetry. This would be x equal h equal minus b over 2a. A is 1, b is minus 13. So this would be minus 13 over 2a, which would be 2. So the x value of the vertex is 13/2, which is also the axis of symmetry. And then the k, or the y value, would be f 13/2 is going to be 13/2 squared minus 13 times 13/2 minus 8, which is 169 fourths minus 169 halves minus 8, and you can write this all in fourths. 169 halves is minus 338 fourths, and minus 8 is minus 32 fourths, which adds up to minus 201 fourths. So the vertex is 13/2 and minus 201 fourths. The y-intercept is x equals 0. You plug 0 into f of x, and you get minus 8. Since a is more than 0, it opens up. Now, here's a problem I made up, but it just sort of shows what you have to do if you want to get a rocket to escape, overcome gravity and allow the rocket to travel beyond Earth into the solar system. So I made this one up. Notice a lot of these, where you're going against gravity with an initial velocity, it starts off at minus 16 t squared. Well, we added what I call a warp drive to make this plus 32 t squared, plus 1000 t, plus 500. And really, if you could develop one of these, it would go on forever and ever and completely leave our galaxy in time. This is really not a practical thing. We can make this happen for a little while and get a satellite into orbit or go beyond our solar system. But this is just what would happen if you could do that. And we just want to know in 100 seconds how high the rocket is. So we just need to plug in and get h of 100 is equal to 32 times 100 squared plus 1000 times 100 plus 500 is equal to 320,000 plus 100,000 plus 500. So in just 100 seconds, it's gone to 420,500 feet, which is pretty fast, faster than my car goes. Now we want to determine without graphing whether the given quadratic function has a maximum value or a minimum value, and then find that value. Well, first of all, a is minus 11, which means it opens down, so it has a maximum value. And we need to find h equal x equal whatever the axis of symmetry, and then find the vertex. So h is minus b over 2a. A is minus 11. B is minus 2. So minus b over 2a is minus 2 over 2 times minus 11 is equal to minus 1 over 11. So the axis of symmetry is x equal minus 1 over 11. To find this maximum value, we have to plug in that value into the function. So the max is going to be f of minus 1 over 11 is equal to minus 11 times minus 1 over 11 quantity squared minus 2 times minus 1 over 11 minus 7. So this is equal to minus 1 over 11. This is plus 2 over 11. And this is 7 is 77/11. So this would be minus 77 over 11, which is equal to minus 76 over 11. So the maximum value, the vertex, is going to be, well, the vertex is minus 1 over 11, and the value is minus 76 over 11. So the maximum value is minus 76 over 11. Okay, we want to find the zeros of the function h of x equal x squared minus 11x plus 28. This is a quadratic function. If you don't remember how to factor, you can always use the quadratic formula. In this particular case, I'm going to start off factoring this function. And notice that x squared minus 11x plus 28 can be factored into x minus 4, x minus 7 equals 0, which leads to x minus 4 equals 0, and x equals 4, x minus 7 equals 0, and x equals 7. So the zeros are going to be 4 and 7. Now, if you're caught, can't remember how to factor, you can always use the quadratic formula. X equal minus b plus or minus the square root of b squared minus 4ac all over 2a. Notice a is 1, b is minus 11, and c is 28. So we'll plug in and get x equal minus b, which is minus 11, plus or minus the square root of b squared, which is minus 11 squared, minus 4 times a, which is 1 times c, which is 28. And this is equal to minus, is equal to plus 11, plus or minus the square root of 121 minus 112 all over 2, which is equal to 11 plus or minus the square root of 9 divided by 2, which is 11 plus or minus 3 over 2. And so your two zeros become 14 over 2 and 8 over 2, which would be 7 and 4, which is exactly what we got up here. So if you can't remember how to factor, or if it looks like it's very complicated to factor, you can use a quadratic formula. And by the way, you can't always factor quadratic. So very often you use the quadratic formula. The number 14, we want to find the zeros of the function g of x squared plus 4x minus 165. If you're good at factoring, you can get the factors as x minus 11 times x plus 15. You'd have to notice that 165 is equal to 11 times 15. Set those equal to 0, and you get x minus 11 equals 0, or x equal 11, x plus 15 equals 0, so x equal minus 15. If you didn't see what the factors are, you can use the quadratic formula and get x equal minus b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to 1, b is equal to 4, and c is equal to minus 165. So x equal minus b, which is minus 4, plus or minus the square root of b squared, which is 4 squared, minus 4ac, which is 4 times 1 times minus 165, all divided by 2, which is minus 4, plus or minus the square root of 16 plus 660, all divided by 2. X is equal to minus 4 plus or minus the square root of 676 divided by 2 is equal to minus 4 plus or minus the square root of 676 is 26. So we get minus 30 over 2 and 22 over 2, which is minus 15 and 11, which are exactly the ones that we got by factoring. Using the quadratic formula always works. Sometimes you can't factor. In this case, you could if you could factor the 165. We want to determine what kind of change is represented by the function below. 0.001 times 1.08 to the x power. Notice as x gets larger, the 1.08 gets larger for x as x grows. So this would be exponential growth. Basically, if x is years, this would be growing at the rate of 8% a year. So even though you might start out with a very small amount, notice that if x equals 1, the first year, you're 0.00108. But if you then plug in x equal 100, you'll get a much larger number, 2.1997. And if you go to x equal 200, it will be up to, if I multiplied all this outright on the calculator, get a very large number. So it's exponential growth. By the way, if this number had been less than 1, for instance, 0.5 to the x, it would be exponential decay. Now we have the value of a brand new video game depreciates at 30% per year. How much will a $200 video game be worth in 7 years? Well, the factor then of the value at the beginning to the value at 1 year later is going to be 0.7. So if it was worth $200 at the beginning, it'll go down by 30% or be worth 0.7 times the initial value. So we have a value equation. V is going to be equal to 200 times 0.7 to the t, where t is the number of years after you bought it. So if you want to know the value in 5 years, it's going to be 200 times 0.7 to the 5th power. And put this in your calculator and you get $33.61 is how much the value of the video game is after 5 years. Just like, you know, value of computers go down, values of cars go down. Now, the last problem here, and I actually knew about this when I was in California building satellites. The value of homes in California increased rapidly. Now, let's say they increase it about 15% per year. In 20 years, how much would a $100,000 home be worth? And we went around to the nearest dollar. Well, the growth factor is going to be 1.15, is 15% per year. So if that is the growth factor, the value is going to be $100,000, which is the initial value of the house, times 1.15 to the t power, where t is years. So in 20 years, it's going to be $100,000 times 1.15 to the 20th power. Put this in your calculator and you get that your house is now worth $1,636,000. $636,000, 654 more dollars. This is all rounded off to the nearest dollar. So you have a $1.6 million house if you bought it for $100,000 20 years ago. And this is the test 3 review. Good luck to everybody.